Hello everyone. Now we will see what is functional dependency in DBMS. Understanding functional dependency is key to solid database design. It supports data integrity and reduces redundancy, preventing anomalies. And why it matters in database management systems. It ensures data accuracy by organizing data into well structured tables. Also, it reduces redundancy, meaning the same data is not unnecessarily repeated. Also, it prevents anomalies like insertion, update, and deletion anomalies that occur due to poorly designed database schemas. Next is what is functional dependency? The definition is attribute A functionally determines attribute B if A uniquely defines B. Means in a relational database, a functional dependency exists when one attribute uniquely determines another. Like A determines B means if two tuples have the same value for attribute A, they must have the same value for attribute B. Here we can see the example employee ID determines employee name. ID uniquely identifies each employee's name. This implies each unique employee ID is associated with only one employee name, and the purpose for this functional dependency is these functional dependencies help us to define the relationship between attributes and are essential for normalization. Next, we will see trivial functional dependency. Definition is B is subset of A in A determines B, always true. This means a dependency is trivial if the dependent attribute is already part of the determinant. The example we can see employee ID and employee name are determinants of employee ID. By means we employee ID is part of the left hand side. So this dependency always holds and does not provide new insights. Effect is it provides no new information about data relationships. Trivial dependencies are mathematically valid but not useful for normalization or database optimizations. The next is non-trivial functional dependency. The definition is B is not a subset of A, shows meaningful relationships. Means a dependency is non-trivial when the dependent attribute is not a subset of the determinant. And why it matters? Non-trivial dependencies represent real relationships between data fields. They are crucial for understanding how attributes depend on each other. There are some types of non-trivial functional dependencies. It includes full and partial functional dependencies. These types help in identifying whether a schema should be normalized to 2NF or 3NF. Next is full functional dependency. The definition is removing any attribute from a breaks dependency. Means a full functional dependency means the entire determinant is required to determine the dependent attributes. Means dependence B depends on the entire attribute set A. Suppose if we have a table called product and order. There are product ID and order ID. If we change product ID, then order ID will also we have to change. This is called fully functional dependency. You need both product ID and order ID to find quantity. Removing either attribute will break the dependency. Example is product ID and order ID as earlier we have seen. Importance in DBMS. Why fully functionally dependence is important in DBMS? It helps us to detect composite keys where all parts are necessary. It is important in achieving second normal form, which requires eliminating partial dependencies. So, next we will see what is partial dependency. Partial functional dependency is some attributes of A can be removed and dependency still holds. What is dependence? In this, B depends only on a subset of attributes in A. Means, if an attribute depends on part of a composite key, it's a partial dependency. Example is so the example is product ID and order ID are determinants of product name. Only product ID matters. So only product ID is sufficient to determine product name. So this is partial, not full. If you have a table of product ID and order ID, then product ID is sufficient to determine product name. Means we can achieve the product ID by using the product name and product ID by using the product ID. So we don't need order ID in this table. So we will remove this from the table. And why it is important? Partial dependencies indicate unnecessary repetition. Removing them is essential to move from 1NF to 2NF. Means we can convert our table from 1NF to 2NF. So next is transitive functional dependency. The concept is if A determines B and B determines C, then automatically A can determine C is a transitive functional dependency. What are the issues in this dependency? It can cause redundancy and data anomalies in tables. And we can see this in detail. A transitive dependency exists when an attribute depends on another indirectly through the third attribute. So we can see example employee ID determines department ID, department ID determines department name. So employee ID determines department name is a transitive dependency. Employee ID directly determines department name. Problem it causes lead to data redundancy. If a department name changes, you must update it everywhere it appears. What is normalization impact in this? Transitive dependencies must be removed to achieve third normal form. To perform this transitive dependency, we will convert our uh, unnormalized table to third normal table. So next is significance of functional dependencies. What is the purpose? It helps design normalized schemas minimizing redundancy. Means if we have a unnormalized table and repeated values in that table, so we can remove that by using functional dependencies. What is the impact? Improves data integrity and eliminates anomalies like insertion, update, and delete. What are the use cases? Fundamental in achieving BCNF and third normal forms. Uh, from this video, we have learned what is functional dependency and what are their types and why it is important. I hope we have learned about functional dependency. Thank you.